everyone. Today we are going to learn 5.7 variation of parameters. Okay, so what is variation of parameters? So variation of parameters is a method to find the particular solution with non-homogeneous equation. Okay? All right, so we have P naught or P sub 0 of x and P sub 1 of x and P sub 2 of x times y, right? So second derivative for the first term, first derivative of second term, and just the y. And other side we have non-homogeneous, right? Okay, now can you see that here we have polynomial in terms of x? Yeah. So previously we had a coefficient, right? Okay, now if we have non-homogeneous equation, then we have y sub 1, y sub 2 are solution of homogeneous equation. Then we have a general solution, y equal to particular solution again here, like a previous section, plus complementary solution, right? Okay, then how do we express complementary solution, right? So there will be c sub 1, y sub 1, plus c sub 2, y sub 2. Okay? All right, now we want to derive the formula. Okay, so let's take a look. We have particular solution. So we want to make u sub 1, y sub 1 plus u sub 2, y sub 2. So u sub 1, u sub 2 is not the constant. All right, so it's functions. All right, okay, then if we want to derivative, then first term, we are using the product rule, right? So u sub 1 prime, y sub 1, that is f prime g, and plus f g prime, then y prime of y, y sub 1 prime, right? Okay, now second term, we want we want to derivative, right? Same, using product rule, so f prime, which is u sub 2 prime, y sub 2, plus g prime, which is y second prime with u sub 2, right? Okay, now I want to make, what is this? So this underline, right? So we want to make this one equal to 0. So we called this is arbitrary condition, okay? All right, then from here, not here, okay, from the particular solution, right? So let me write down particular solution. So let me write down. So we have particular solution has u sub 1, y sub 1 plus u sub 2, y sub 2, right? Okay. But then we had y prime, y sub, it's hard to read. Y sub 2, y sub, y sub p, so particular solution, we derivative, first derivative, right? We got that. But then we said this is 0, right? If we have this is 0, then remaining is only this. Sorry, only this. Yeah, can you see that? U sub 1, y sub 1 prime plus u sub 2, y sub 2 prime. Yeah, let me write down. since I want to write down this one. Make sense to you? P. Yeah. Okay. Now, what we are doing. All right. So we want to make a y second prime from the first prime, right? So we have only this, and then other one is equal to 0, right? Okay, now we are using product rule. So the first one, f prime, will be u sub 1 prime, y sub 1 prime, plus fg prime. So f, which is u sub 1, and prime will be y sub 1 second prime, right? That's how they got it, right? Okay, now second term, we want to use product rule again. So u sub 2 prime, y sub 2 prime, plus fg prime, which is u sub 2, y sub 2 second prime. Whew. Yeah. Okay, now this is in the beginning we start with, right? With a polynomial second linear equation with a non-homogeneous equation, right? Okay, now we substitute y prime with a particular y second prime, not the y prime, y second prime, and we substitute y prime with a particular y prime, right? And then y, we have a particular equation there, right? Solution, equation solution, yeah? Okay, so we substitute everything. So let me rewrite. So that will be y second prime, this will be y prime, and this will be y. Yeah, make sense? Okay, now they said in the beginning, right? In the statements, y sub 1, y sub 2 are solution of that homogeneous equation, right? So we have equal to 0. All right, then look, this one we distribute first term and second term, first term with the second term, first term with the second term, right? That's how they got it here, equal to f. But then if we have this form, then this is 0, right? Okay, this form will be here and here. Then there will be 0. And then they have a same factor, which is u sub 1 in here, u sub 2. Make sense to you? Okay, third term, whatever they have, yeah, and equal to f, which is f of x, yeah. Okay, now, since this is 0, this is 0, only remain last term with f, yeah. Okay, now, then what's the particular solution? Particular solution will be c sub 1, y sub 1 plus c sub 2, y sub 2. Okay, then just rewrite this one here. And then we had arbitrary condition which equal to 0 from this one condition. Yeah? Make sense to you? So this one rewrite here. Okay, now rewrite this one with, rewrite this one without p sub 0, right? P naught, p sub 0. So if we divide by, so right side we have f of x over p sub 0. Yeah? So arrange that. So we multiply by top y sub 2 prime, and we multiply y sub 2 for the second equation, all right? Okay, then we distribute. This is how we got. And y sub 2 we distribute. Then that's how we got, okay? All right. Then second term we can cancel out because 0. All right. Then we have only first term and this one left. Okay, now we want to solve for what is the u sub 1 prime. Then we divide by whatever we have, both sides. Then u sub 1 prime will be negative f of x y sub 2 over p naught y sub 1 y sub 2 prime minus y sub 1 prime y sub 2. Okay? All right, so we do same process for, oh, not yet. Hold on one second. We haven't finished yet. Okay, now, how do you find the u sub 1, right? So we want to find the u sub 1. Yeah, let me write down. Solve for u sub 1. Okay, so it's u sub 1 prime. So how do you solve for u sub 1? We integrate to get the u sub 1, right? Okay, then we integrate both sides. Then, okay, all of a sudden we say that whatever inside in the parentheses, we said omega. Yeah, we had omega earlier, right? Remember? What is called the Wronskian, right? Method, omega. Okay, so it's a 2 by 2 determinant. We are using it. Okay, so let me finish here. So minus, we have integral of f of x, y sub 2 over p naught and y sub 1, y sub 2 minus y sub 1 prime y sub 2, right? This one, how we get in short term, right? This is a Wronskian 2 by 2 determinant, right? So why? Because look, we have y sub 1, y sub 2, and then y sub 1 prime, y sub 2 prime, right? So we multiply this way, right? So y sub 1, y sub 2 prime minus y sub 2, y sub 1 prime, right? So can you see that? So we can make a short, this one is, which is omega, yeah? That come from 2 by 2 determinant, Wronskian, right? Okay, now, whew. All right, then how do you solve for u sub 2? Same process. If we do same process, like u sub 1, then we get f of x, y sub 1, p naught, and omega there with the integral. Make sense? Okay, now this is the formula we're gonna use for this section. All right? For what is called the variation of parameter. All right? Okay, now let's take a look at the example. So look, we have an example, particular solution of, look, everything, the first term, second term, third term. The third term is constant, but first term, second term, polynomial in terms of x. Yeah, can you see that? It's different, right? With the previous sections, right? Okay, we have f of x, the function, right? Yeah, in terms of x. Okay, It's not the polynomial, right? So polynomial must be integer. Okay, now non-homogeneous equation, right? So given that y sub 1 equal to x, y sub 2 equal to x squared, our solution of complementary equation, right? Which is equal to 0. Then we need to find the general solution, okay? All right, so let me write down. So the first job is we want to make the P naught the first term of the polynomial, right? So we want to get rid of that, right? So let's see, this is P naught, right? So we want to divide by P naught every term. Okay, then that will be y second prime minus 2 over x, y prime plus 2 over x squared y equal to 9 over 2 minus 2, 2 times 2, so it's a 4, 5 over 2, right? So there will be f of x, yeah? Okay. So, no way. Hold on 1 second. This is f of x, right? And then we divide by x squared, which is p naught, right? Okay. Now, what we are doing? Complementary equation. So, we have let complementary equation, which is c sub 1 y sub 1 plus c sub 2 y sub 2. Okay, c sub 1 y sub 1 in that case is x. Copy? Given. So we have x plus c sub 2 y sub 2 x squared, right? Okay, now we make a, what is called? One scan 2 by 2. Before we do that, let us find the particular solution. So we have particular solution. We u sub 1, y sub 1, right? Y sub 1 plus u sub 2, y sub 2. There will be u sub 1, x plus u sub 2, x squared, right? Okay, now the formula, right? So formula we have, copy. Oh, let me just copy everything then. Copy. Okay, I need a new page. I will make it smaller here. How about that? Okay, we have that, right? Okay, I want to find u sub 1. So u sub 1 minus integral f. F in that case, x to the 9 over 2. That's the f, right? And x to the 9 over 2. And y squared? Y squared is x squared over p naught. P naught will be x squared, right? Or we can use that. We can use f over x p naught. Let's work, right? Make sense? Okay, let's using this one. So that we can, we don't have to do work, right? So 5 over 2, 5 over 2, right? Then we deal with this one, right? We wrote down this one, y squared. Now, omega. So omega is 2 by 2 determinant. So there will be, how about, let us do this one here. Let me write, ooh. Okay, I need to move. 1 omega will be y sub 1 x and y sub 2 x squared, y sub 1 prime, which is 1, y sub 2 prime, which is 2x. And we multiply. So x times 2x minus x squared, yeah? 2x squared minus x squared, which is 1x squared, which is x squared, right? Okay, so there will be x squared. We can simplify. And in that case, we have to make a dx, yeah? Because we want to express in terms of x, yeah? Okay, now we will get minus x to the 5 over 2. We integrate, then add 1. That will be 7 over 2. So that will be 7 over 2, negative 2 over 7. That's the use of 1, right? What about the use of 2? So we are using f over p naught, which is the same x to the 5 over 2, right? So we will get x to the 5 over 2 power y sub 1, which is x, right? Okay, there will be x over omega 2 by 2 determinant x squared. Okay, so we simplify. So we get, it's a 1, right? So x to the 5 over 2, and then x, then 5 over 2 minus 2 over 2, which is a 3 over 2, right? So we have x to the 3 over 2. Then what do you get? X to add 1, so 5 over 2, 2/5. Yeah. All right. Now, particular solution will be u sub 1, y sub 1 plus u sub 2, y sub 2. Okay. And then we had y sub 1, y sub 2 already, right? So I wrote down earlier. Maybe we can using this one. Copy? Paste. Yeah. Okay, so what is the u sub 1? U sub 1 will be negative 2 over 7, x to the 7 over 2. We have x plus u sub 2. We have 2/5 x to the 5 over 2 times x. Yeah. Combined, right? So we have 2 over 2, so 9 over 2. plus 2 over 2. So we have a 2/5 x to the 7 over 2 then. Did I make a mistake? 7 over 2. Oh, sorry, I made a mistake here. X to the second power here. X to the second power. So second power, so 9 over 2 as well. Yeah, 9 over 2. Okay, we have the same power, then we can make a common denominator, right? Combining, so we have 35 negative 10 plus 14 x to the 9 over 2, which is 4 over 35 x to the 9 over 2. Yeah. Okay, now general solution. We have y equal to particular solution and complementary solution, right? So there will be the last one, 4 over 35 x to the 9 over 2. And the complementary solution we have just right there, right? 6 of 1x plus 6 of 2x squared. Yeah. 6 of 1x plus 6 of 2x squared. Make sense? I don't have to rewrite, right? So complementary solution, right? So here. Make sense? Okay. Let us do second question. Yeah, so given y sub 1, y sub 2 here, and then GS means general solution. Okay, so we need to find the general solution. Okay, let us do this. So from beginning, so we want to make only y second prime, right? There will be divided by p naught. So we have to make other side form f of x over p naught. Yeah. Okay, so let's do that. So this is a p naught. So divide by x minus 1. So we get y second prime minus xy prime over x minus 1 plus y over x minus 1 equal to 1. Simplify, so we got only x minus 1, right? Okay, so there will be f over p naught, right? So we can use that later on. All right, so let us using Wronskian omega. So omega, which is y sub 1, y sub 2, y sub 1 prime, y sub 2 prime, right? Okay, so y sub 1 is given right there. So x and e to the x. So y sub 1 prime, which is 1, y sub 2 prime, which is e to the x power. We multiply, so we get x e to the x power minus e to the x. Yeah. Okay. Now, u sub 1, f of p naught, and then y sub 2, yeah. So let me make a quick, right? So u sub 1 will be negative f over p naught. So we can use that. and then y sub 2, y sub 2 with omega in the denominator. Yeah. Okay, so negative, we have x minus 1, y sub 2 is e to the x power, and over, we have x, e to the x minus e to the x. Yeah. Okay, now we can simplify this one, right? So we can factoring out e to the x, x minus 1, right? Okay, let's using that so that we can simplify here, right? So we will get e to the x power. Easy, right? Yeah. Yeah, so I can use that same color. Yeah, so we simplify everything, it's 1, right? So we will get negative 1 dx. Yeah, then what do you get? We get negative x. Very good, right? So y u sub 2, we have a positive f over p naught, and then y sub 1, and then the omega there, right? Okay, so that will be x plus 1 for f over p naught, y sub 1, we have x over e to the x, x minus 1. Yeah. Okay, that will be, we can simplify. So we will get x e to the x dx. Okay. Ooh, what do you do? Can you think? All right, so let me bring, hold on 1 second. Let me bring that integration by part, all right? Can you recognize? Okay, so this is an integration by part from calculus 2, right? So we want to set it up, which one is the u, which one is the v, right? So T for setting up u. So I called liate easily to remember because L stands for log function or natural log, right? And I stands for inverse of trig function, and A stands for algebraic function, which is a polynomial, and T stands for trig. And then E is exponential function, like e to the x. Yeah. Okay, now e to the x is a very last, right? So we set up x. This one we consider as algebraic function polynomial, okay? All right, so let u equal to x. Then we have the formula, how to set it up to find the little bit complicated the integral, right? So uv minus integral of v du, right? Okay, we know what's u, but then we don't know what's v. But we know what's the dv, right? Okay, from dv, how did we find v? Right, so we make an integral dv to find the v, right? Okay, let us do that. So v from integral of dv. So in that case, integral of dv, which is, look, e to the x power is in the denominator, right? So e to the negative x then, yeah, dx. Okay, then, what's the integral of e to the negative x power? So it's e to the negative x over negative 1, which is the same as negative e to the negative x power, right? So negative e to the negative x power. Okay, now let us do this. U, which is x, v, which is negative, I put the negative in front, e to the negative x, minus integral v, which is negative e to the negative x, du. What is the du? 1, right? So du will be 1. Okay, so we have 1 dx, actually 1 dx. Yeah, okay, so 1 dx. Okay, there will be negative x e to the negative x. And this is a positive. What's the e to the negative x? Which is once again negative, right? Negative e to the negative x plus c. Okay, so there will be the answer will be negative x e to the negative x minus e to the negative x. Then there is a particular solution, right? With the u sub 2, we can use that, right? Okay, that's the u sub 2. Okay, so hold on 1 second. We don't found anything. Yeah. Okay, then let us arrange. Yeah. Complementary solution. Which is c sub 1, y sub 1 plus c sub 2, y sub 2. So c sub 1, y sub 2, I'm sorry, y sub 1. I'm using here y sub 1 x, y sub 2 is e to the x. Yeah. X plus c sub 2, y sub 2 is to the x power. Particular solution, we have u sub 1, y sub 1 plus u sub 2, y sub 2. And u sub 1, we have that earlier, u sub 1. Let me see. Negative x. Way in the top, yeah, negative x. And then x plus u sub 2 we found negative x e to the negative x minus e to the negative x. And then y sub 2, which is e to the x power, right? Okay. Then let's simplify. So negative x squared. Oh, we multiply. Then we get, look, this one, we have a negative x. And then second term, negative x plus x is 0, right? So let me write down for you. Negative x e to the 0 power and minus e to the 0 power 2, right? Yeah. Okay, so there will be negative x squared minus x minus 1. Yeah. Okay, now general solution will be a particular solution with complementary solution, right? So there will be negative x squared minus x minus 1 plus c sub 1x plus c sub 2x squared. I'm sorry, e to the x power. It was in the earlier, right? Okay, that is the one. Make sense? Okay, very good. Ooh, okay, the last question for this section. So let's find out. Okay. So same concept. Um, oh, you know what? We want to make a peanut, right? So in that case, it's 1. So we don't have to no, no. Divide. There's nothing. Yeah, so there's not unnecessary divide by 1, right? Every term, right? Okay, so it's already, this one will be F over P naught there. So we can use this one. Make sense to you? Okay, let me write down. Copy. So this will be note F of X over P naught. Yeah, we're gonna use it later. Yeah. And P naught equal to 1. Okay. What we are doing then, the wrong scan, which is 2 by 2. So y sub 1, y sub 2, y sub 1 prime, y sub 2 prime. Okay, so y sub 1 cosine 2x, y sub 2 sine 2x, and derivative of cosine negative sine 2x times 2, right? So negative 2 sine 2x. Okay, now derivative of sine 2x, it's cosine 2x times 2. Yeah, so 2 cosine 2x. Multiply, so we get 2 cosine square 2x minus plus and 2 sine square 2x. Yeah. Okay, now we can see that, right? Pythagorean identity. So 2 cosine square 2x plus sine square 2x. We knew this is 1. So we will get the 2, right? I'm talking too much today. Okay. All right. Now, u sub 1. So we have u sub 1. Let me remember. So we have a negative integral f of p naught, and then y sub 2, then omega 1 scan, right? Okay, so there will be negative. We can use the sine 2x secant square 2x. That is f of p naught. And y sub 2. Y sub 2 will be, I can use this one. Y sub 2 is sine 2x. Sine 2x. Now, over 2, right? Wow. Over 2 dx. Okay, what can you see? You cannot see anything? Yeah, sine square 2x. Yeah, so we can see that minus sine square 2x secant square 2x over 2 dx. Yeah, what can you see? Yeah, we can see that secant square 2x 1 over cosine square 2x. Yeah. X over 1 over cosine square 2x. Okay, now what can you see? We can express this one. Tan 2x square, right? Which is the same as tan square 2x. Yeah. Unnecessary steps. I just want to show you, right? Okay, now what can you see? Tangent square 2x, right? So let me make a, tan square 2x, we have, note, the Pythagorean identity, right? So Pythagorean identity. So 1 plus tan square x equal to secant square x, yeah? Okay, then tan square x equal to secant square x minus 1, right? But we can just using 2x there, right? So there will be minus, we will get secant square, hold on 1 second. It is, right? Secant square. Hold on 1 second. Do I make a mistake? Yes. What happened to 1/2? Yeah. Sorry, 1/2 is missing. Yeah. Okay, so there will be 1 plus tan square x, secant square x. So tangent square x equal to secant square x minus 1, right? So 2x minus 1 dx. Yeah, makes sense? Okay, now let's integrate term by term. So we will get, let me rewrite in the denominator, I'm sorry, in the bottom. So negative 1/2 integral. We don't have to do that. So negative 1/2 secant square 2x minus, minus is positive, right? And 1/2 dx is okay. Yeah. All right. Okay, so let's think. What's the derivative to make us a secant square x? It's been a while, right? Derivative of tangent make us secant square x. Okay, so what if we have, what's the derivative of a secant square 2x, right? I mean, we think about that. Yeah, antiderivative, right? So reverse. Okay, then tan x derivative, then secant 2x, secant square x. Then tan 2x derivative and times 2, right? Then we get the secant square 2. Sorry, no, it's not the one. So tan 2x, right? Derivative secant square 2x times 2. We get that, right? Yeah. Then we do antiderivative, then 1/2, right? Make sense? So there will be the first term, negative 1/2 tan 2x 1/2 there, plus and 1/2 x. Yeah. Okay, so let's arrange. That will be 1/4 tan 2x plus 1/2 x. Yeah. Okay, so what we are trying to find is, so u sub 1, how about u sub 2? U sub 2, we have integral f over p naught and y sub 1, right? and omega, right? Okay, so there will be f of p naught, f of p naught, this is better. Sine 2x second second to the second power 2x. And then y sub 1 will be I'm using cosine 2x over omega. Yeah, so omega will be 2. Okay, dx. All right. Did I make a mistake again? Hold on 1 second. Yeah, it is good, right? So I want to express secant square 2x like earlier as other trig functions. So that will be sine 2x and cosine 2x. Secant square 2x will be over 1 over cosine, right? Square 2x. So we have 2 cosine square 2x. Yeah. Okay, that means we can simplify with 1, right? So there will be sine 2x, cosine 2x, sorry, simplified, over 2 dx. Yeah. Okay, now, what can you see? No, hold on 1 second. We have 1 left. Cosine 2x left, right? So cosine 2x. All right, so look, let u equal to sine 2x, derivative cosine 2x, right? So we have 1 over u du, then what do you get? Natural log of u plus c. So there will be cosine 2x, right? No, wait a minute. Should be cosine, reverse. I'm rushing, sorry, I'm rushing, so u equal to cosine 2x, yeah. Sorry about that. Derivative minus sine 2x times 2, yeah? Okay, that will be 1 over 2 then, yes? Yeah. So negative 1 over 2 and cosine 2x plus c, yeah. Or you can use integral of tangent 2x because sine 2x over cosine 2x, right? So let me write down for you. So sine 2x x. Okay, so that will be negative 1/2 ln cosine 2x plus c. Yeah. Either one, it's okay, right? Yeah. So we get, the answer is -1/2 natural log cosine 2x. But then we have 1/2 there. So let's using that. -1/4 cosine 2x. Okay, so almost done. Let's rewrite, right? So complementary solution will be c sub 1 y sub 1 plus c sub 2 y sub 2. So c sub 1 y sub 1 y sub 1 cosine 2x, y sub 2 is sine 2x. Cosine 2x plus c sub 2 sine 2x. Okay, complementary, no, hold on. Oh my gosh, crazy. Particular solution, u sub 1, y sub 1 plus u sub 2, y sub 2. So u sub 1, we had, this is u sub 1, right? So let me copy. And u sub 1, y sub 1, y sub 1 will be cosine 2x plus u sub 2. Just stop there. Copy. And y sub 2 is sine 2x. Yeah. Okay, general solution will be all together. So general solution, y equal to particular solution plus complementary solution, right? Okay, so there will be y of x equal to whatever we have. Let me just copy. No, there is no negative, right? And this one is particular solution. Yeah. Let me just using positive there. And this is easy. Copy. Okay, so you guys understand this? Do you understand this? All right, so seems like a lot of work, but it's not, right? Yeah, you can do it. All right, thank you for watching. I will see you in the next video. Thank you, bye.